Welcome to Summarize Science, where we explore the frontiers of technology. Have you ever wondered why robots struggle with simple chores like wiping a table or peeling a potato? It turns out that vision alone isn't enough. Humans rely heavily on our sense of touch to understand the physical world. A team of researchers recently introduced OmniVTA, a system designed to give robots this missing piece of the puzzle. Most current robots follow preset movements, which makes them clumsy when something unexpected happens. To solve this, the researchers created a massive dataset called OmniViTac, featuring over 21,000 different robotic movements. This dataset covers 6 different types of interaction, including cutting, grasping, and even wiping surfaces. They used 4 different types of advanced tactile sensors to capture high-resolution data on how objects deform under pressure. Their analysis showed that touch is especially important for tasks that require constant contact, like adjusting a tool in a robotic hand. The core of their innovation is a world model that actually predicts the future. This model allows the robot to imagine what a contact will feel like a few moments before it actually happens. They developed a special component called tactile VAE that turns complex touch signals into a language the AI can understand. Another clever part of the system is a gating mechanism that decides when the robot should trust its eyes and when it should trust its fingers. For example, if a camera is blocked, the robot automatically relies more on its sense of touch to finish the job. They also included a reflexive controller that operates at 60 frames per second. This acts like a human reflex, allowing the robot to instantly correct its grip if an object starts to slip. To test their creation, they put the robot through a series of difficult real-world challenges. They even tested it with objects it had never seen before, like a different-shaped vase or a new type of knife. The results were impressive, as the robot successfully completed tasks that usually cause standard AI to fail. They found that predicting future touch states was the secret sauce for keeping the robot steady and accurate. In visual comparisons, you can see how the predicted touch maps closely match what the robot actually feels in real time. They even tried to mess with the robot by bumping into the objects it was holding. Because of the fast reflexive system, the robot was able to recover and continue its task without dropping anything. This level of robustness is a major step forward for robots that might one day work in messy human homes. So, what does this mean for the future? By combining vision and touch into one predictive model, the researchers have made robots much more capable of handling the physical world's unpredictability. This could eventually lead to robotic assistants that can help with cooking, cleaning, or even delicate medical procedures. The massive dataset they have shared will also help other scientists build even smarter machines. This research proves that for a robot to truly understand our world, it needs to do more than just see it. It needs to feel it. Thanks for watching Summarize Science, and stay tuned for more amazing tech breakdowns.